Today we are going to start that rigidity modulus. See, as consider a bulky book or stout or fat book, say A, B, C, D. This is a fat book, right? Kept on the table. Kept on the table. Now, if you press a palm on this and on the palm on the face of the table, this is the face of the book, and move the palm just like that. If you move the palm parallel to the table, right? What will happen? You are applying a tangential force. What force? Tangential force on this face. Because of that, what happened? The you are applying, when you are applying a tangential force, then you are then set to apply a shearing stress. What stress? This is called force per unit area. Force per unit area. This is called shearing stress. Shearing stress is what? Tangential force per unit area you are applying it. Because of this, what happened? There is the stress. Because of the stress, what happened? This portion, A changes to A dash, B changes to B dash. There is a deformation, right? Previously it was like a rectangle, and theta is the angle of deflection, you can call. This vertical side AB deflect through A dash D. Therefore, as a result, the stress, the book undergoes what? Deformation. That means previously it was what shape? It was a rectangle. Now it has changes to what? Parallelogram. It changes to a parallel. What shape it was? Rectangle. It is changed to parallelogram. And theta is the displacement. Now theta is the measure of strain. That is shearing strain. That means shearing strain. That means x is the displacement and this is the vertical side. L remains same, right? L remains same. And there is a displacement here also. Same thing. There is a displacement from here to here. Therefore, theta is a measure of strain. What strain? Shearing strain. That means the angle is the measure of shearing strain. The shearing strain theta is always equal to tan theta. Tan theta is equal to what? Opposite over adjacent. Now, according to this, rigidity modulus is equal to the ratio of shearing stress to shearing strain, right? Shearing stress is equal to what? Force per unit area. That is called shearing force. And strain, what strain is called? It's called shear. This is called shear, theta. But theta is equal to x by L. Therefore, I can write F, A and theta. Now, theta can be written as what? N is equal to F, A, theta. F, A, theta is equal to x by L. This L goes up. F, L, AX. This is the formula, right? Force per, this is also Newton per meter square. Now the rigidity modulus is this. Therefore, same thing I am giving in the form of giving the notes. Here you have to write the rigidity modulus N. You can understand here. Keep your start book on the table. Press your palm on the top of the book and move the palm parallel to the table. You are then set to apply shearing stress on the book. Force per unit area, right? As a result of the stress, the book undergone deformation. That means what passes as rectangle becomes what? Parallelogram. Right? Parallelogram. Therefore, shearing stress is equal to what? Tangential force per unit area. This is called tangential force per unit area. It's called stress. And due to the stress, the vertical side AD displaces to AD or CB displaces to DA dash and BB dash, CB dash. And through an angle theta. The theta is a measure of shearing strain, or simply shear you can call. The shearing strain is equal to x by L, opposite by L. Then according to this, rigidity modulus is what? Rigidity modulus is equal to ratio of stress by strain. Stress is called force per unit area. Then the simplification, how I have done this. Right? Therefore, this unit is what? Newton per meter square. This has no unit. Right? Therefore, the entire notes you have to write it once. They may ask you for 2 or 3 marks.